So I guess that's a no then, eh?
I'll read it after this class. It's not that long, right?
It's long. That's why you gave it to us over the weekend.
Summary.
I didn't read it. That's why I was asking if you did. So you've got green eyes, so you've got blue eyes, so you've got gray eyes. Oh, you've got green eyes, oh, you've got blue eyes, oh, you've got gray eyes. Oh, up and down, turn around, just to let me get down. Find myself cycling.
Oh no.
Down, turn around, please don't let me hit the ground. Ooh, I don't have class after this.
I'm sure you did right.
Did what right?
Dwayne, how'd you do on the problem set?
Some more problems.
So put in the problem set for MI3.
Go ahead.
I checked with like 5 people and I got a C+. My grade is now a solid 85.
Solid. I want shoe bread. That's not right at all, actually, because of all the variables in space. That's not right.
It's perfectly right.
It's wrong.
It's right.
It's completely wrong.
It's right.
What's that? Ew. Oh, down to please don't let me hit the ground. I'm tired. I want to drop out of the bridge.
I thought my first class was going to really stink this morning, and it was great. So let's just keep it rolling.
Goodbye?
Yeah. You know, we showed videos of Earth being destroyed by asteroids. Kind of raises everybody. Wow, look at that long list. A whole bunch of stuff. So now the quest. We had 3 quest assignments. One was due last week. The other was going to be due on the weekend, but I was thinking most people probably weren't thinking about it. So I moved it back to tonight rather. So the second quest, due tonight. Third quest on Newton's Laws is due Wednesday, and it's always been scheduled. Everybody has their Newton's First Law lab back and turn it in. It's not in Power Studio, but anyway, you can look at it, you can look at the comments. So that redo is going to be due Wednesday night. Nobody needed to retake data, so it's just a matter of looking at it, maybe cleaning up the way that you say things in advance, because you'll need to be a little more precise in how you describe things, say on the exam, which is Thursday. We have an exam. And although we have 100-minute class period, we devote 60 minutes to the exam. Now, I've got about half of the Newton Second Law labs done. I'll probably get the rest done today. So I'm thinking the due date will be Friday, because that way you've got I-Day. If you want, you'll have Thursday after the test. And I know there are some people that, a couple of the traces just didn't turn out, where somebody described something to me that didn't make sense. So I asked them, better show me your graphs for, transferring the weight from the top to this side to make sense of what I was reading. So because people have to maybe go back in and take some data, I want to make sure you had at least Thursday in class. And like I said, you can come in on Wednesday, bring an ID to do that too. So most likely lab 2 and 3, if I get them back to you the next day or so, and you have class time on Thursday, both of those would then be due on Friday. Buggy Sparky, which is the first lab of the next unit, that's scheduled to be today's activity. And so if you're on schedule, you're doing that. If you're kind of playing catch up, then maybe you need to come on Wednesday to do that. But in any event, that's going to be due on Saturday. So you have today, you have I-Day, you have a little again, you've got some of that time after the exam. Questions for me? So it's a specific thing, or do you think it's of general interest? right, we'll just talk about it once we get to the preview. Now, the scoring on your labs and the sections of your tests, they're a bit chunky. You know, we're not doing like, 92, 87 and a half, that kind of stuff. We're going to go 95, 90, 85, 80, etc. And the idea is, well, you get to redo it. You get to redo your test once, you get to redo your lab once, and then at the end of each quarter, we give you like one more freebie. We'll say, like, you've had 3 tests, is there one you want to take a third time? So, and each of those can be raised back up. But now here's the thing, and this is hard for some students to appreciate. A perfect score on the exam or the lab is not 100%. It's 95. Okay? And the idea is that if you get an A, 95, and you get a B, 85, they average to be right there in the middle, 90. And if we started giving 100%, that would mean, you could have an A and 2 Bs or something and still be getting an A average. It doesn't make any sense. So you probably need to tell your parents this too, and be like, well, why aren't you doing better than 94 and a half? 95 is the best in any category, except the Quest. You can get a perfect score on the Quest. So look at your lab. If you have less than a 95, if you have a 90% or 85, whatever, resubmit. Now, if you have a 95, don't ignore it. I do put comments in there. I'll say something like, well, this is worded a little awkwardly. You want to do better to get full credit on an exam. So don't assume because you got 95 that everything's in there perfect. But do not resubmit it. I'm not going to rescore it. That is the highest score you can get. And if you still have a question, just ask about it. Eunice.
So 95 is the highest score for
Anything that you can redo, test and lab. The Quest you can actually get 100% because that's an automated thing. Oh well. So you get a little bit. Other questions? Okay. Here are the 2 biggest things I saw on the first 2 labs. On the Newton's first law lab, do not call inertia a force. Sorry. Inertia is not a force. Okay? You cannot overcome inertia the way you can overcome or match another force. So, if you apply a force to an object and you have, say, friction equal and opposite, yes, they negate each other. It's 0, there's no change. But if you take and apply a force to something that's incredibly massive, okay, it isn't negated. It isn't a problem of overcoming. It just means the change will be really, really, really small. Like when I accelerate towards the Earth is accelerating towards me. It's not an equilibrium. I haven't not overcome its inertia. It's just so big, the change is really, really tiny. And so where this showed up is when you were telling me that the pull from the tablecloth, the friction on it was not enough to overcome inertia. What would be a better way to word that? Take a moment, touch it, and see what you take. Pretend it's the exam. How are you going to word it on the exam?
Let me see.
You're checking how you worded it before?
Yeah. Oh, I didn't say anything like that. I just said that because the friction is so small, it only moved slightly since the force was so quick. What did you say?
I said the plates didn't fall because they were at rest and stayed at rest because of inertia. And then he wrote about it being time sensitive, it was really quick.
Yeah.
And the friction counteracted that, and so they stayed.
What'd you have?
Just so everybody remembers, in case it's been too long, where you let your partner go.
Jack, want to go try?
So we didn't overcome inertia. This thing didn't respond, right? It started to move a little bit. It accelerated a little bit. Now the question is, So the frictional forces go on, you say, oh, first of all, this thing should travel then forever, albeit slowly, and off the edge. And we don't have that problem. Why? Yeah, so the little bit of friction here, well, we started accelerating, now it experiences on the table and it quickly decelerates. Okay. And so another sort of faulty answer was saying, well, friction wasn't enough. It wasn't strong enough. You need to be a little bit more specific because, well, sure, friction is strong enough, right? I can pull this onto the floor. So it's a matter of how big friction is and how much time you're giving it to act. Remember, it's accelerating the whole time it's applied, but if you don't apply it very long, it doesn't get to accelerate very much. But if you give it a nice long time, even a weenie force that was can do that. Does that clear up for people then the two major things I was seeing? And even some people who got 95% the perfect score and that, some go back and look at your wording there, make sure it's going to be tight and crisp. All right, that kind of leads into the Newton's second law. Again, yes, question?
So the inertia is kind of a way to summarize the like friction and the
It is not a force. It's why you need force, right? It says that this object will resist the change you try to make. And that's why you need force to make change. If you got a lot of inertia, you're going to need a lot of force, or at least apply it for a long time.
but the friction is what causes
The mass of the object. The measure of inertia is the mass of the object. So if you have a lot of mass, you have a lot of inertia, and vice versa. So that brings me maybe to the third part, where people will say, when you hold the clock quickly, you reduce the inertia of the object, or actually increase it. That inertia was variable. And of course, it can't be. It's tied to the mass, and the mass hasn't changed. That's not a valid statement. Other questions about Newton's first law, or the lab, or anything? Okay, so now in Newton's second law, when you were diagramming, object on the table, take a moment, dialogue with the people at your table. What are the legit, now keep in mind, a lot of stuff going on, there's table, there's pulley, there's hanging mass and everything. We want to diagram the cart. The cart is our object. The cart is whose position and velocity we're plotting, nothing else. So if I said, give me the free body diagram for the cart, tell me what are the forces that are acting on cart. And maybe we'll talk about things that aren't forces that people wanted to put diagram. Talk to each other.
This is what I have.
What was this?
The cart, the fan cart.
Was this the second one?
Oh wait, looks like we're doing the wrong cart. Okay, I guess we have to do the one with the weights. Okay, this is what I have for the weights.
What did I turn in?
I didn't add the weight part.
That was the fan card. Yeah, here's what I did.
Yeah, I didn't add the weight part. So basically, it
We
was
didn't
just
put-
like that.
We were supposed to put tension force too, which
That's what I-
we didn't have at the moment.
I didn't know about that.
I put
Yeah.
tension force, but I didn't put the weight.
That's okay, you might be right. Like, it might not be weight, it might be the tension force.
Okay, so somebody acting on gravity of Earth. Okay. Force of gravity, being real specific now, Earth on cart. Perfect. Let me give you another one. Yes.
of the tension of the string.
Expansion of the stream. I like that. So now you can call that capital T, you can say F sub T, and if we want to get really precise again, we'd say string on cart. What else? Now, depending upon, in the directions they tried to tell you in the lab, assume it's minimal overweight, but let's say you went ahead and put it in there. How big, given what you saw in your graphs, how big would you make it? Would you make it equal to the tension, or bigger than the tension, or smaller? Okay. You see, and why does it have to be smaller?
Velocity is increasing
Because there's acceleration, there must be imbalance. You could say the generic F. If you wanted to be specific, you could say air drag, surface friction, whatever you want. But the sum of all those things had to be less than the tension. Okay. Anything else? Units. Okay.
You have to be that specific on the test.
I like to see this, but if you told me force of tension, you told me normal force, if you told me gravitational, and if you told me air resistance or the combined friction, I would accept that. Okay. Where this is going to be handy is when I start asking for the third law pairs, and then you're going to have to be that specific because I need to know which half of the pair you're talking about. All right. Is there anything else that belongs in this diagram? Because some people wanted to put inertia. Is that appropriate?
No.
No. It may seem like it's acting like a force, but it's not a force. But I like the direction, at least the idea that it's retarding the change. Now, other people were calling this other things. Some people would say the weight of the hanger force. What do you guys think of that? You say, well, I can kind of see that now. Why not? Why do I need to call this tension?
Well, the weight of the neighbor isn't a force directly acting on the cart. That causes the weight causes the tension directly acting on
Okay. So look at it from the perspective of the cart. You're only going to put things that touch the cart, with the exception of gravity. Right now, gravity is the only force that we're using that acts through space. Everything else has to make contact. The ground, the string, the rough surface. Everything's in contact. Now, from the cart's perspective, it doesn't know what's on the other end of that string. It could be a hand, it could be a spring, it could be a hanging weight. Oh well. So later, when we have to start putting numbers on it, then of course we'll start looking at this to decide what that number should be. All right. Questions, please? Was this helpful? We wasted time? No? No. But I feel like that's the bulk of what I saw. Everything else was kind of minor. All right, so today's topic, we're moving into a new unit. So if the force was why things move, now kinematics is talking more precisely about how to describe that. Comes from the Greek word kinesis, to move. And the first things we need to do are kind of establish how we're going to measure stuff. So let's say, all right, so here we are. Oh yeah, some of this is New York. So we're going to go on a road trip, Chicago to New York. You know, maybe it's next year and the Bears are playing the Giants for like the NFC Championship. You can all hear me. What do I need to describe that trip? Getting in the car, driving, say, I-80 or whatever, getting to New York City. Velocity. What else? Yeah, keep going. Acceleration. What else? Position.
But you can't know where to stand out this. That's good.
All right. I don't know this number exactly in my head, but I would say if I ask you, well, what else might you keep track of besides, putting into your phone how far apart those two places are, occasionally looking at the speedometer in case, you see a trooper off to the side. Is there a way you could decide how long this trip should take? I mean, you pack sandwiches for the afternoon, is that gonna get you there? You stop it? How fast legally should we be driving? 70, 65 maybe in Pennsylvania or something? All right. And how much over can you go before they come? 5 to say? All right. Some rules of thumb. We're going to do everything in metric, and we're all, myself included, are used to this darn English measurement, which when I was in second grade, they told me, we're going to be changing soon. It's only beyond in the United States and like 500 countries, and here we are still miles. Benchmark, conversion, miles per hour to meters per second. Do you know a handy rule of thumb there? Let's make what up? Rules of thumb. Okay, 55 miles per hour is essentially 25 meters per second. And since you're telling me the crazy speed, I guess I noticed that. Let's say we tend to go about 30 meters per second. How long should this trip take us? Talk to the people that you're taking.
For what, 30
We
meters per
won't worry
second?
about the stoplights, getting on the freeway. When we get out and go, we're not having flat tires on the S.
How many meters in a kilometer?
How long should this trip take us?
I thought it was like 1,000 or something.
1,000. Okay.
I need a
Divided
new
by
document for this.
30.
It's in the same folder.
Divided by 60 is that many minutes.
How did we do that?
Let's see how many hours. 13.8 repeating hours.
How did we do that?
Because you do 1,500 times
How did
1,000.
you do it in the search?
Oh, that's, you just type in a math equation and it will show up. So 13.8
So in
repeating
the
hours.
neighborhood, I'm hearing in the neighborhood of 14 hours. Being
Yeah.
precise, you're saying 13.8. Okay. How did you get that? We'll put it this way, you better get up early, start the day early, leave at like 7, get there at 9, of course you gotta stop, eat and stuff, so it's the whole thing.
So we have like 59 kilometers, and then but we have 30 meters per second, so we have to convert 59 kilometers into meters.
Okay. So, one thing you need to know are the Greek and Roman prefixes. So km, kilometer, how many meters is that? 1,000. All right. So units over here. 1 kilometer equals 1,000 meters. Okay, so he says, let's convert that. So now we have 1,500,000 meters. And we do. Keep going.
And then we know like this is equals rate times time.
So distance, nice one, equals rate times time. So we might put a V there, and we might put a T there. And how did you know that?
I just do it from.
Let's say you get real nervous and you lock up on that exam. Is that rate times time, rate divided by time? How would you quickly sort that out? First.
It's like a unit, right?
There you go. We know we need distance in meters. We know we have our rate in meters per second. Now, I need to multiply this by seconds to cancel the unit and come out with meters. So I know I have to multiply by seconds. There, I recreated the formula if I got nervous. All right, so we go ahead and do that. We do our 30 meters per second, and we said this was 1,500,000 meters. And we solve for seconds. Time in seconds equals what? 50,000. And then we start dividing by 3,600. So, 50,000 divided by 3,600 seconds per hour. And we cancel the units, and we end up with our 13.8. Everybody good with that? Comfortable with canceling units? All right. Now, how is distance different than position? Where it is? Let's say we made up a coordinate system. Of course, Chicago is the center of the universe. So, if we call this 0, then New York City would be plus 1,500,000 meters. And let's say, that'd be San Francisco, might be, well, let's say it's twice as far away. What number would I put there? Negative 3 million. That's why the 49ers are in the Super Bowl. All right. So position, that's plus and minus. Is distance ever negative? No. But we're going to need to keep that negative sign. Our equations won't work if we use distance. So we're going to define displacement. And we're going to say it's the change in our position, our coordinate. And we're going to say it's always final minus the initial. So if I said, what is the displacement, Chicago to New York, what would you tell me? First you know the number, right? Yes?
So it would be New York, which is 1,500,000 meters. Subtracted from 0,
Minus 0. So we end up with a plus 1,500,000 meters. Okay. What's our return trip? New table, please. What's our return trip? Zoe? There you go. We would say our final 0 minus our 1.5 million. So displacement New York to Chicago is negative 1,500,000 meters. Okay. Now, I could define the trip. I could have said Chicago to Toledo. I could have said Chicago to Reading, Pennsylvania. What if I say round trip? Chicago to New York to Chicago. What's that going to be? On your table for a second.
And if it's 0, you'd end up, or would you do it like in increments?
Isn't that what we just did?
But he's saying together, what would it be?
So if you end up in the same place, wouldn't you just do 0 and not change?
Well,
Or would you do it like in increments? Like
it depends on like if we're talking about where you end up or if we're talking about the trip itself. If it's the trip itself, then if we're talking about distance or position, if we're talking about position, then yeah, it would be 0 because that would be displacement. It's 0, yeah. Yeah. Because we're not talking about distance, we're talking about position.
Yeah.
Yeah.
position or distance. So if we're talking about positions, there's going to be 0 because
You end up-
going back in the same.
If we're talking about distance, then it would be 1.5 million times 2. But
So
since we're
30
talking about
million?
position,
Oh, 3 million.
or since we're talking about position, and it's just like talking about where you started and where you end up, it would be 0.
Okay, what is your displacement? Chicago, New York, Chicago.
0.
0. That seems rather stupid. I mean, we did this on purpose to help us, and it seems like we threw away everything that we were interested in. And yet, this is exactly how we're going to do it. We're going to define velocity based not on distance, but on displacement. So we're going to say velocity equals our displacement, and then of course, how long it took. But we're going to, has anybody heard the word instantaneous before? So when they pull you over, are they pulling you over because your average velocity wasn't so good, or was it your instantaneous velocity that you like? What is it? What do they write you the ticket for? Yeah, the highest moment that they were able to measure. But we're giving our formula. We don't know quite how to do instantaneous yet, so nobody's being ticketed here. But we just defined average. And I'll put the bar over that to mean average. And in fact, I'm going to put a third bar on my equals. Has anybody ever seen that before? Or does that just look goofy? You seen it, Bert? Sorry? Say it a little bit on it. Okay. The way I put it there is I'm not saying not only are they equal, but I'm defining these things to be the same thing. So I put that third bar. This is my definition of average velocity. It's my displacement over my time. So now we had our 30 meters per second going out there, 60 miles an hour, that'd be like 90 kilometers per hour. And then we probably did kind of the same thing coming back. You know, tailwind doesn't really mean anything for cars. What was our average velocity over the entire trip? 0. Again, seems goofy, but that's how we're going to have to do it. So it's really up to us to define a meaningful interval. That's our chore, to always pick an interval that makes sense, because you choose round trip like that and you're basically throwing all the useful stuff away. But this is how we have to define it. Now, the things that you're interested in, speed. How would you define speed? Take a moment, talk to the people at your table. If we're defining velocity as displacement over time, how would you define speed?
Distance over time.
Oh.
Units.
Yeah, that makes sense.
Distance over time instead of displacement over time, because distance is actually distance is always positive.
So changing distance over change of time.
Distance over time.
Kind of a sleepy lecture on this. You know,
You are so unhelpful right now.
I get that a lot.
Ryan and Josh.
Velocity is displacement over time.
Yeah, I got that.
Sometimes you might want to get back.
Hey,
It's
hey.
the change of x over the change
How
of
would
y. It's
you
not the change of
define-
displacement over the change of
You just told me that.
Average speed. No ideas? You have the whole internet at your fingertips. You have all those brains, at least 3 extra brains at your table, and not a single idea. Distance over time. Okay. So, Okay. Now, we might say this makes a lot more sense, right? You go 1,500,000 that direction, another 1,500,000 that direction. You've got 3 million meters, and you've got, in the neighborhood of 27 hours or so. That's a meaningful number. But we're not going to do it that way. You may say, well, why? But it will become apparent as we go on and build our more sophisticated equations. They would fail if we tried to use this. And this will be consistency. And again, it's just up to us to make sure we use meaningful intervals. Right.
So will the average velocity be the change in position or displacement over the change in time?
Correct. Is that not what this says to
Or
you?
speed as well?
Oh, so you're saying, well, no. See, here, you go plus and then minus, you get 0. Here you go 1,500,000 east, and then you go another 1,500,000 west, and you just add it. This is the sum of all the little pieces, and it didn't matter direction. All right. Now, most of what we're going to do is a matter of going in one dimension. We won't do a lot of two-dimensional stuff. And so you can define a direction based on your coordinate system. And so plus, if you have a plus velocity, that would mean in this case you were traveling east. A negative velocity meant you were going west. So let's say I'm like driving to the Badlands in South Dakota, and I get pulled over. You're going 85. And I said the sign says I can't go above 80, right? I was doing negative 85. All right, but for us, plus and minus is how we're going to judge direction. Now, acceleration. Whether we like our definition of average velocity or not, by analogy, I want you to come up with your definition of average acceleration. And go ahead and base it off what you see. Talk to each other this here.
I have no idea.
What are we doing?
Acceleration.
The change in speed over the change in time or something?
Change in velocity over the change in time.
That makes sense to me.
Yep, I think so. Acceleration. So,
Velocity is the change of displacement over the change of time, right?
no, just displacement over time.
What's delta x divided by delta y?
That's the change. That's displacement over time.
This one?
Yeah,
That's displacement.
yeah, displacement over time. Velocity over.
All right. We don't want to strain Josh. I need other volunteers now. Zoe has already, you've already. Who has not already volunteered? Vince, were you volunteering? Probably not, but I'll take that as a possibly yes. Go for it.
Average acceleration is the change in velocity over the change in time.
There you go. We're just going to say change in velocity over the change in time. Oops, change in time. And again, based on how we use our Greek delta symbol, this will always be final minus initial over, and you could say, same for your time, your final time minus your initial time, if for some reason it wasn't zero. Okay. So, anybody here follow drag racing? Anybody know what a good car, fast car's acceleration might be?
500 miles per hour?
That sounds like a very high speed or velocity to me. But, so, let's figure out what those units should be. Okay? If this was meters, and this is meters per second, what do we have over here? What are going to be our units of acceleration? Meters per second per second. Meters per second per second, or meters per second squared. How many meters per second it changes every second? Now, let's say we go down to like Michigan Avenue, Columbus, wherever, or Madison, wherever that 0 point is for Chicago. And a lot of drag strips would be a quarter mile. So that's 1,500 meters for a mile roughly. So we'll say like 400 meters is our drag strip. You know, Usain Bolt can do it pretty fast, but we're going to use a car. So here, I'm just going to blow this up a little bit. Here we got our starting line, here we got our finish line, 400 meters, and we're starting from rest. If you're flipping through the magazine of your high-performance consumer cars, not the actual drag racers, what kind of times do they give as their quarter-mile time? Sorry? Nobody actually enjoys looking at the specs for fast cars, Shelby Mustang or anything. So let's say it's like, that's an expensive car. It's going to cost you $50,000 to go. And they don't usually say 400 meters. They'll say 0 to 60 or whatever. So we'll say we're going 0 to, we're going to use our conversion. We're going to go 0 to 30 meters per second. And we're going to do it in 5 seconds. And oh, by the way, our drag strip faces west. Calculate for me the average acceleration during this little illegal experiment. Well, I guess if you hit all the lights right, but I don't think there's any city streets that are 60 miles an hour.
So going 0 to 30 miles a second in 5 seconds is 6 velocity over seconds does not seem like a thing. 6 meters per second is the acceleration. The west. Can acceleration.
Remember, our car magazines, they aren't thinking velocity, they're thinking speed. So when they give you, 60 miles an hour, they're just telling you speed. We got to convert that to metric. We've done that. We've got to decide what's plus and minus, and then calculate our average acceleration and see if it was worth that 15,000.
Less than 6 meters per second. 6 meters per second. Then it's probably wrong. Yeah.
So Emily, I heard a number. Don't tell me. Don't say it. Do you guys have a number? Grant, do you have a number? Consult your table mates. What about back there? Eve, do you have a number?
Mm-hmm.
Who's got a number here? Whoa! Whoa! What about back there? Timothy? You got a number? All right, Taylor, do you have a number? Tell me, are there cool pictures today? No, good. All right. Can you take a moment and talk to the people at your table? I needed to hear a number from you, like one. Okay. Did everybody agree at these other tables? Everybody's getting the same one? Did you all agree on the sign?
Mm-hmm.
We're going west.
Yes, but it's acceleration, it's not distance. Since we're accelerating, like if we were going slower, it would be negative, but since we're going faster, it's positive. Why did you take my eraser? You realize that I'm not blind. Okay, without my glasses.
Okay.
Take off your glasses.
Taylor, what kind of number do you come up with? Wait. You need to write it down.
So does the where you're going even matter?
Not for acceleration.
Okay. 8. Oh no.
Start at 0 and you zoom to the west. So your speed at the end of the force is
They're not wearing red and
and velocity will be negative. So negative 30 minus 0.
You better tell Miranda.
So that gives you negative 6. All right, so is everybody getting negative 6 meters
No.
per second squared? Okay?
No.
So you say, all right, I start at 0. So using my formula, I'm going to put in a 0 there. I finish at 30, but I'm going west. That's negative. So
No.
minus 30, subtract 0, divided by the elapsed time, which is 5 seconds. And so I get my negative 6 meters per second squared. What's gravitational acceleration? Are you- 10. So I would do better, just push this thing over a cliff. All right, maybe not. Anyway, do people understand this calculation? The number, the sign, and everything? Yes? Anybody hazy? Yes? Oh, if we were measuring it in terms of distance. But to go from there to here is a lot more painful than to go turn it into speed velocity. It's a lot more direct. Now, the rest of the week, we're going to be building up formulas that will take you from position to acceleration. The difficulty is we've got to define some more stuff. We can't be using averages. We're going to have to start using those instantaneous ones. And we're going to be making assumptions. We can't solve every problem you could imagine without calculus. So we're going to define ourselves to a subset that we can do with basically algebra and geometry. Okay? Question? Exactly. Right. Okay, I'm going to turn you guys loose. Remember to be on track. You should be doing Buggy Sparky. If you're playing catch up, and you can afford to because you're going to come in on Wednesday or whatever to get caught up, remember the things that are due tonight, the couple things that are due on Wednesday, and I'll come in and out. Buggy is easy. Sparky is fun, but a little bit dangerous. So I'll come in
Ooh,
here
dangerous.
to demo it, and then I need to be present anytime somebody's, generating the 50,000 volt sparks. Hertz.
Oh, we used to see hertz.
All right, so you guys begin to work. The lab is on.
Let's go kill something.
Alright, seems like
Oh, you sparked me.
Let's go.
We have this one part of the E versus T graph.
Correct. Exactly. That says whatever forces you have to be balanced. Whatever your engine is doing through the wheels to the ground needs to be matched by air resistance, resistance, internal friction, and all the sliding parts have to be equal. Or moving up will start to change speed. So you kind of have to work that one backwards. You have to go with what you know to be true and what that means also has to be true. But you know you can't take your foot off the accelerator, right? Or you slow down. And that's because those other frictional forces are real and are significant. No, there would not be. If you're at a steady negative 30, there can be no acceleration. So whatever force, say from the engine, has to be balanced by an opposing force, say from some form or collectively all forms of friction. Can we talk in here so I can demo some stuff? Yes? Can you follow me? I want to get them started on Sparky.
No, I finished now.
You finished it?
Okay, if I can have everybody's attention.
Yeah, so do the Sparky.
I'll demo over here, Bucky Sparky, and then we'll hand out.
Wait, Rob, what do we still have to do with this Sparky left?
So, as he is demoing, you take some tape, you rip it up, you give yourself a couple meters. Now you're gonna need some room. So maybe pull the and see, is the car's acceleration constant? And what you're gonna find is
You already know where she's going for property tax.
but then after a fraction of a second, it's a lot. Now, we plug this in, we have a little punch that's tied into the electric current. It's going up and down as much as the cycle here. And since we're in the United States, we cycle 60 times per second, 60 hertz. That's how many times that's going up and down. Dots.
You have the
Of course,
song.
if you do on top of it,
Just for one.
Average interval velocity is 80%.
Yeah, velocity is 80%. Acceleration is 80%.
Check your chart, you get 80%.
Should I go for this question? You do breathing and why? Breathing? Your body is no. First of all, first, what did you do? Made the fucking out.
So about the same distance as.
You have to live this life and the take home. Oh man. 3-hour mandatory.
Chart, and here's the thing. You might be inclined to say that was.
Oh, he said well said for that question. You wanna know what I said? It was like very well said, like explanation.
You don't want.
You just have to do the three negative parts. You need to finish it. When you're doing trouble. We can do something fun. What do you like? It's so easy. You just circle the regions. Activity or don't stay with my mind.
Hey, what you use this is slow down.
You don't have it yet, but you just have to know what you do. And you're wrapping or on the data system.
It's the average change in velocity.
You're gonna graph it. We have to do the velocity versus time.
Yeah.
You're gonna understand what points on your calculator.
I'm gonna take all the changes, right? Every change in velocity. Yeah, them up, and you divide it by how much the average.
But the idea of.
That's the average. Wait, what does it mean that there's no constant velocity?
Setting up. Okay, so here.
And if you're using second. Wait, what do you write in the blanks? No, that's for the oral.
So to have
Right, for second, for three of the people who viewers.
Spark
We used to discuss I'm in small class. No, I didn't. Who do you think this started? I don't know. Wait, what's the other question? Because you only get before. Oh no. You have the BSc, tutor, common law. Is common law the same thing as the Viking? No. Okay, so then Viking, what's the last one? Okay, common. So that's two. Wait. Are you done? You just know wait.
I don't have any markers. Come on,
I have like a bajillion Sharpies in my
Okay, well
bag.
then grab a Sharpie.
Do you want a specific color?
Yeah, purple.
Purple? Alright.
I just need. I'm doing study session, IRC, after study session. I know, but I still need to. IRC. Yeah, I'm always in IRC. Just work on it. Unless there's so much other work to do, which I probably will. You want to
Like for the test.
no, for we're starting IRC. That's so easy. I don't even run a fraction class. It's dihydrogen tetrafluoride. Okay, so use dihydrogen. No, I or suffix no, like anything at the end. Also, it's like I or I. Fluoride or something. Really? Really don't have any. I'm gonna read a 9-page thing for Ellie. I don't have Ellie or nothing. I don't know. Sleep. I'm done. We use a BC class long BC class. No. You didn't even tell me anything new. We'll learn new stuff on tomorrow. Finish worksheet class. I love that stuff.
Or pieces of data. Okay, I've written on the board how you want to set up your spreadsheet, what you're doing in your head or the formula for the board over there, and what it would look like in Excel.
We're very smart.
No, so it's E16, E15 minus E7 divided by C15.
As Eunice cleverly points out, there is a ruler at the edge of all the collision tracks. So we've got a couple of loose rulers that are close.
Hey, Vince. Wait, minus C6 or minus C7?
Minus C7 is your velocity or
Isn't each dot,
Hold on.
a tenth of a second apart? Isn't it a millisecond?
It says 160.
it says reasonable value.
Not even go. Just the way.
E15 minus E7, E15 minus E7 divided
All
by
just for minutes, right?
what? Okay, I think. Number 2.
First point position is behind zero position, or
Wait, if you didn't pull it up, it's a
Yeah, no. So don't attack it. It's not an issue. So don't attack it. Then 6. You're 30.
and market.
no, I mean, that's his name.
We have measuring tapes. I realize they're a bit clunkier than rulers.
Dinner. I'm not going to do that. I don't want
So here's a good question. You and your partner have exactly the same data. Can you share that data once it's been calculated? I would prefer you to be able to. So I want, even though when you're done, we're looking exactly the same. I still would more or less do it yourself so you understand. You have to be able to like yourself. And the quicker
We're
you
gonna knock at these. We don't get No, we'll just give us more time to work through the stuff. Or if we get a worksheet, we'll still have these. And then, I already finished and stuff.
These are still the
Do you guys
same.
want?
In terms
Did
of
you, wait,
pattern.
I'll have it. And then each one. Yeah. So basically, I want to be fit in the near future, like,
Yeah, I got it.
so I just have to read or. Okay, I'm ready. I'm ready. I'm ready. Wait 1 second. And then push on the phone. And I will be because it's in constant motion. Oh, yeah. You got that one?
Oh, it's in constant general energy.
Oh, okay. Read, quest, lab, and read. And reading. Okay. Read, quest, lab, and read.
Wait, what's average?
Oh, just reading. But I already know how to make my. Yeah, I didn't get it at all. It was like what's happening. I have 2 pictures of
Diagnos dish. Diagnos dish.
onions and cat. Anion and cation. Annie and then cashier. Yeah, that's positively charged.
Now,
Anion. It's an ion. Annie and cashier. Wait, where is that presentation?
we're having to go to velocity calculation. Now,
Is it ion? Maybe ionic compound. Wait, what's the difference between what? What's the difference between what and it? I have all of them written down.
Brad, can you send us a graph?
Yeah. No graph.
Yes.
So the average equation. I know, but you have to say like, that doesn't show. Magnesium oxide, calcium, water.
So all forces.
Wait, I am.
Steady. No acceleration.
I thought I'm 96 on that. Wait, where's that? But if you make 2 questions on an answer, because you won't get it. Because you'll never get James Mystery documents. Wait, he graded it already? No, he fell asleep. Alright,
So
now
you
I
guys all did one sparkly last night.
Yeah, like you showed it to us. We did.
I remember. Yeah, I remember. You guys are gonna do buggy sparky another time or already done? Cool.
Dr. Collins Sparky last second, and then he did it for us.
Okay. Didn't set anything up.
I had a question about the slope of the velocity versus time graph.
Okay.
What I did was changing velocity divided by changing time.
Okay.
And it gave me this value, but it's saying it's incorrect. But then here it's saying it's wrong.
So it didn't like your math equations, but it said zero.
Because on the cell, it should work. From the average velocity, it gives correct, but we didn't think centimeters exactly.
It makes sense, it's a reasonable value. Why, you have the data table. I don't have the data. Oh, I want to copy and paste. Actually, I can't. Show a sample calculation for the average interval velocity. 120 minus 0.0.
Mr. Carlson, we wanted to lay out striking.
Okay.
I already messed up. Or it was like,
For each of 4 engines is 50.
There's just a calculator. Just copy. We're going to the sample calculation. Can you do 4 minus 2 about like 0.05? The sample calculation, can you do 4 minus 2 divided by 0.75? But what's the class?
How can you say that that's ever?
More? 4. That's a lot.
So the lowest difference is 1.
So if the data points can buy outside. It's the 98%. How much
It's
is it?
1 standard. It's 68% actually.
Right, 61
1 standard.
And then 58% of it, percent 99. So we can reasonably assume that the lowest is going to
Well, consider the fact that they need to watch it.
or like, because you know how it increases every time you finish it. Yep. I just think there's a lot of time.
That looks like a lot.
One question. The one after doing the calculation. Hold up, you want? Okay, I'll just do it. Is that converted to seconds? Numbers converted to seconds. Or I'm good with that. With 68.8 times 68. Is it 60 or not? Like, you want that many miles per second? No way. Or miles per minute. So, okay, that many miles. Wait, did you get 68.8 miles per hour?
66.6. But then if you multiply by 16
Why?
because that's mile, 1 mile is 50.
And then you divide by 30
And then you divide by 30.
So you divide by 30 kilometers per second. Consider a moving object whose position as part of the function of time t. I think it's yeah, so you can have that fast.
He doesn't have speed. Speed is
Because it went the longest distance over the no. Is speed in terms of displacement? Velocity? No, velocity is in terms of displacement. Yeah. Velocity is in terms of displacement. Speed is just sum of distance.
I'm including the answer.
How do you
Hey, what do you guys think about the trend in the graphs?
I haven't done that. Did you already make the graphs? You sent them to me. You can send me the graphs. Yeah, we can share a graph. Wait, is 3? Why?
Why? Because speed is always positive.
Yeah, speed is in terms of distance. Even if you're going backwards, it's still a positive.
How do you spell it?
SREENIVAS. During which interval did the object's velocity remain constant? 1. Number 3 is so many. I think it might be a trick question. Wait, no, I think it's all 3. Do you think it's all 3? I got it wrong. It's not 1. Yeah, it's all 3. It's a lot. I got my first class question wrong. Go ahead, really? This is not me, because we gone. I think it's all 3. So I looked at that and it said turning into a 1. I'm not answering this. This is called deeply. No, Jerry, this is terrible. Change in displacement is a velocity. What? I got, yeah, it's all 3. I got it. All 3. You can do this. Position versus time. Oh my goodness. Yeah. No. That's what 96. Oh, position versus time. So if you find the equation for that graph. Good luck with that. This equation is an equation for this. That's how. I think it's negative 1. Position. Ellie. How's it negative
8, minus 5, minus 13.
Wait, where are you getting this?
Right here.
Yeah, we have different graphs. We do? Yeah.
Oh, here's the same as that.
We just show you.
So I have this right here, right? So at 8,
No.
it's the same as 10.
8 was
8, minus 5, negative 13.
Oh.
So you got 1, 2, 3, divide by 7. Yeah, so it's per.
It's velocity. It was negative last time, or it's
Yeah, well, when I put an acceleration negative, it didn't work.
because acceleration isn't negative.
Acceleration negative.
It is?
Yeah.
Velocity negative works for me.
Did it work for you? Okay, no.
Wait, negative 7 minus 5.
whatever these equations, right? What's plus?
Or that's like it's actually.
No.
Yeah. And then we're
Executive order, changes,
yeah, let's change distance.
from the line.
We'll change distance at,
Those zero same.
no, not zero. We're looking for at 6.5, right? So what, you need that curve, that slope. Yeah, but this is,
We're using the existing laws to change these.
oh, bro. And then,
Collect them all. And it's like,
dude, read the numbers. Oh. Yeah, -9, and what's your nine? I'm so wrong already.
Do you think it would hurt if you go through fingernail? It'll shock you, but it won't kill you.
So it'll hurt, but it won't. You won't die.
Talking about?
50,000 volt.
Depends on your handbrake.
Unless you're like really have a bad heart, a bad heart, you're probably not gonna. Yeah.
That'll kill you.
Not enough hamburger.
Might kill you. Hold on.
You don't, it's not gonna, it doesn't have enough hands. Unless you got, it looks like that one hand.
Yeah. Well, it's going from the wall, right?
It's coming from the wall, which is it.
The wall tower can kill you, right?
If it had enough voltage, you're not gonna die. Unless you have like an arrhythmia in your heart, you're not gonna die from stupid yourself.
That's a lot of hand.
Huh?
That's a lot of hand.
Yeah, not as terrible.
15 meters per second.
Yeah, 120.
Yeah, you need like to be stopped. You need at least 1,000 volts. Hard to figure out.
It's all about hand. You can die at 40. You can die at 40.
Yeah, as long as it moves. And your average needs to be about.
What do you have?
Six.
You just add the 2.5 hours plus the 21, or plus whatever you're doing. You find the distance traveled and the time, and then you add it to the initial. Oh, you add it? Yeah, that's subtracted. We cowboy. You got that? Guys. You got 2 hours. Plus whatever.
Each dot is a 6.
We are out of time. If you have everything tidied up, you may go.
This table is
I've seen people's answers in centimeters, and the spreadsheet is accepting them as a reasonable value.
Can you please have them back?